All right, this is a video tutorial for the 2.5 section in the Big Ideas Geometry book, proving statements about segments and angles. So the two learning objectives are to write two-column proofs, which is a big thing in geometry proofs, is to have two different columns of the statements and reasons, and name and prove properties of congruence. So we're going to jump right into the very first example at the beginning to write a two-column proof and see it in action right away. So this is based off of example 4 from section 2.4, and I know in this class specifically we skipped that, but this is still the same picture, and you don't need any previous information to look at this example. So we are given the information that the measure marked angle 1 is equal to the measure of angle 3, and we have to prove that the angle of DBA is congruent to EBC. Now, when you are creating your two-column proofs, it's going to look like two columns. So draw like a T-chart, and on the left you're going to have your statements, and on the right you're going to have your reasons. So the left is actual facts that you can say about the diagram, the picture, the situation, and the reasons are your evidence, or the way you can back up why that statement is true. So usually what we do in two-column proofs is the very first statement is our given information. So the first statement is measure of angle 1 is equal to measure of angle 3. And the first reason, or the way we can say that, was it is given to us. The problem says this is a fact, I'm giving it to you, you can use it to your advantage. What we can then prove next is that the measure of angle DBA is equal to the measure of angle 3 plus angle 2. Remember, DBA starts at where the light is in the picture, goes down to the ground, and then travels along the ground. So you're creating two different angles, which are 2 and 3. And in order to find the measure of the total, you're going to add the angles together. So your correct reason would be an angle addition postulate. Now, you don't need to necessarily write those words exactly, but anything related to adding angles or angle addition would be close enough. Then using that same logic to get DBA is that the measure of angle 1 plus angle 2 also gives us DBA, because we were given that 1 is the same thing as 3. So we can replace that previous statement in number 2 where it says 3 and plug in our angle 1, because those two things are equal to each other. So an appropriate reason would be the substitution property of equality. Again, we're just substituting in something that is equal to each other. Then measure of angle 1 plus 2 is the measure of angle EBC, and your correct reason, again, angle addition postulate, because EBC is that one on the right where the light comes up from the ground, and then it travels along the ground to the left, which creates 1 and 2 together for the total. And then we can substitute again the DBA, which we know is the same thing as 1 plus 2, into that number 4 equation because of the transitive property of equality. There were a couple other properties that you've gone over in classes previously. They are all inside the textbook. You're just going to have to rifle through those sections. So some of the properties that you're going to be using for congruency of segments and angles, the main ones are reflective, symmetric, and transitive. So that's what in that first example was for your two-column proofs. So for segments, reflexive property would be if any one segment is congruent to itself. I know that seems self-explanatory, like the number 2 is equal to number 2, but in a lot of situations in geometry, you will have two shapes that are bumped up right next to each other, and they will share the same side, and you will have to actually state that this side equals the exact same side, but from the perspective of the two different shapes that they're up against. Symmetric would just be to rewrite the order of which statement equals which one, first versus second, or second versus first. So AB is congruent to CD, then CD is congruent to AB. Transitive is looking at if two segments are congruent, but that second segment is congruent to a third segment, you can say the first and the third are congruent. So this is an if-then, where you're going to an if A, then AB to CD, then CD to EF, then you can say AB to EF. The same thing can be said with angles. Again, you may have some overlapping angles within two different shapes in a geometry problem. So just simply saying that angle A is equal to angle A is the reflexive property. Symmetric just changes the order, and transitive connects three pieces that are all equal to each other. All right, so naming the properties that are illustrated just so that you get a little bit familiar with them and more used to them. If T is congruent to V and V is congruent to R, then T is congruent to R. Well, these are connecting three different things where the first one is congruent to the second is congruent to the third, so the first is congruent to the third. So this would be the congruence of transitive property, because you're connecting those three different pieces together. And part B, if line JL is congruent to line YZ, then YZ is congruent to JL. Well, this is the exact same thing, but you're just flipping the order of those two. So this would be the symmetric property of congruence. All right, prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is 2 times AM and AM is 1/2 of AB. So again, always helpful to draw a picture. You're going to draw a line segment AB, where M is the midpoint between them. You're given that M is the midpoint between them because you're told that in the problem if you know that M is the midpoint of AB. And you need to prove that AB is equal to 2 times AM and AM is equal to 1/2 AB. So writing that out as an actual formula for your goal of what you're going to end up with will help you when you're creating your proof. So again, 2 columns. Statements on the left, reasons on the right. We're always going to start with the given information because we cannot go anywhere from the given to prove unless we start at the given. That's our starting point. We do know that AM is congruent to MB, and that is based on some previous information from last chapter. That is the midpoint definition. If ever you have something that is the midpoint of a line, then the two segments are equal to each other that it is cutting in half. You then can say that AM is equal to MB just by the definition of two congruent segments. When something is cut in half, those two parts are equal, half of the whole. Then you can add them together. AM plus MB is going to equal the whole. Segment addition postulate. Again, still working through midpoints, cutting something in half. Then you can substitute some pieces in. You know that AM is equal to MB, so I can plug AM also into MB and have two of those together by the substitution property. And whenever you are adding two terms together that are the exact same thing, there are two of them. So 2 times AM is equal to AB, and that is the distributive property. Then just by using algebra to undo what the 2 is on the other side, you divide both sides by 2, which is the same thing as multiplying by 1/2, the division property of equality. Okay, write a 2-column proof for the symmetric property of segment congruence. So usually when you're writing a proof to organize your reasons, again, draw your diagrams for the situation that is described. Always identify what you are given, what your starting point is, and what you need to prove by the end. So let's say you have 2 different lines, LM and NM, and they are congruent to each other. That could be your given statement information. And you need to prove that NP is congruent to LM. Okay, that is the symmetric property, where you are just changing the order of the 2 sides. 2-column proof, statements and reasons. Always start with your given information. LM is congruent to NP. Then LM is congruent to NP is just based on the definition of congruent segments because they are congruent. And then you can substitute those in where the NP becomes the LM and the LM becomes the NP because they are symmetric. And you can just rewrite it as segment congruent definition. And that is the end of the video.